Hi everybody, this is Masood, the electrician. Today we are diving into something that's at the core of electricity: single-phase and three-phase systems. Why do we use single-phase for some things, three-phase for others, and what's the difference? Stick around, and by the end of this video, you'll have a clear understanding of these two systems and why each is used in different cases. Let's start with the basics. For electricity to flow, there must be a closed circuit. Electrons move through a conductor from the source, pass through the load, and return to the source, completing a loop. The simplest system to achieve this is with two wires, one for the outgoing current and one for the return. This forms the foundation of a single-phase system, which is common in homes. It uses one alternating current that moves back and forth in cycles. The voltage rises and falls, providing power in waves. This is sufficient for smaller devices that don't need continuous high power such as lights or TVs. A three-phase system, on the other hand, uses three alternating currents. These currents are out of phase with each other by 120 degrees. This design ensures that as one current starts to decrease, another is rising, creating a continuous and smooth flow of power. This steady supply is ideal for powering larger machines and industrial equipment. You might be wondering, why do we use single-phase systems in homes? The answer is simplicity and cost. Single-phase systems are cheaper to install and maintain. Most household appliances like lights, TVs, and refrigerators don't require a lot of power, so single phase is more than enough. For example, a typical microwave uses around 1000 to 1500 watts, and a washing machine might use between 400 to 1000 watts. These devices don't need the consistent power delivery of three-phase systems, which are designed for equipment requiring tens or even hundreds of kilowatts. The infrastructure in residential areas is built around single-phase power, which meets the needs of almost every home. Industries and high-power applications rely on three-phase systems because they are more efficient and powerful. These systems handle heavier loads, making them ideal for running large machines and motors in factories. Here's an important point. A single-phase system uses two conductors while a three-phase system requires three. However, the power delivered by a three-phase system isn't just triple, it's proportionally more efficient. With only 1.5 times the number of conductors, a three-phase system delivers 3 times the power of a single-phase system. This efficiency is a key reason why three-phase systems are preferred for high-demand applications. In these pictures of single-phase and three-phase cables, note that the green-yellow conductor is the protective earth. This wire doesn't transfer electrical energy. Instead, it's there for safety, protecting people and equipment in case of faults. It's an essential part of the electrical systems, but not involved in delivering power to the load. Another major benefit of a three-phase system is the smooth and consistent power delivery. In a single-phase system, power rises and falls in waves, which can cause interruptions. In contrast, three-phase systems use three alternating currents, each 120 degrees out of phase. This overlapping ensures a continuous and stable flow of power, which is crucial for sensitive or high-demand equipment. For example, industrial pumps, conveyor belts, or heavy-duty machinery depend on the steady and reliable power provided by a three-phase system. So, where do we see these systems in action? Single-phase systems are used in homes, small offices, and for household electronics like microwaves, washing machines, and lights. They are ideal for everyday appliances that don't need a lot of power. Three-phase systems are found in factories, workshops, and power grids. They are essential for running large air conditioning systems, elevators, and heavy machinery. These examples show how each system fits into specific needs and environments. You might be wondering, how do single-phase and three-phase systems work together? This is where transformers play a key role. Electricity is often transmitted over long distances using high-voltage three-phase power because it's more efficient for transportation. When it reaches residential areas, transformers step down the voltage and converted it into single-phase power for homes. This process ensures the power is safe and practical for everyday appliances like lights and washing machines. In large buildings or mixed-use areas, you'll often find both systems working side by side. For example, elevators, HVAC systems, and industrial kitchens might use three-phase power, while the lights, outlets, and smaller appliances rely on single-phase power. This balance allows for efficient power use while meeting a variety of needs. By combining these systems, we achieve an optimal mix of efficiency, cost-effectiveness, and practicality, ensuring that power is delivered wherever it's needed most. To sum it up, single-phase systems are simple and cost-effective for homes, while three-phase systems are efficient and powerful for industries. Both play a crucial role in the electrical world, and understanding their differences helps us see why each is important. Before we wrap up, here is something to think about. Have you ever wondered if engineers use systems with more than three phases? What about five-phase, six-phase, or even higher? Drop your answers or guesses in the comments. I would like to hear what you think. Thank you for watching. If you'd like to learn more about electricity and how it shapes our world, don't forget to subscribe to my channel. See you in the next video.